Pythagorean theorem, where we're going to be reading a story called What's Your Angle, Pythagoras, and where we're going to discover the formula and learn to use that in our math class. But before we get started, we're going to start off with some bell work about the Pythagorean theorem and kind of an introduction before we start reading. So you guys can go ahead and work on this to start. Is everyone finished up with the bell work? Mm-hmm. All right, so let's kind of go over it. So the first question, what type of triangle did you guys decide that was? Yes.
A right triangle.
Yes. And so how many degrees were in angle C then? Yes.
90 degrees.
90. And then does anyone remember what side C was called? Yes.
Hypotenuse.
Yes. Okay. And have you guys heard of the Pythagorean theorem before, or is it brand new to you?
I know about it.
You know about it?
I've heard a little bit about it.
Good. Good. Okay. So since we're going to use that, that's the kind of triangle that you can apply the Pythagorean theorem to. So next we're going to read this story. So it's called What's Your Angle, Pythagoras? And I'll go ahead and hand this out to you. So just to go over a little bit of background before you're just get into the reading. So Pythagoras was a Greek philosopher who discovered the Pythagorean theorem. So he discovered this and put it to use in the math world. And it's a fictional story about how he actually discovered it. So it's not a true story, but it's just made up. So as you guys read, I want you to use some of our mid-reading strategies and go ahead and highlight and underline anything you think would be important or that would help you understand what the Pythagorean theorem is, because that's what our goal of this is, to figure out what the theorem is. And then also any thoughts or questions you have during it, or if you're confused, go ahead and jot that on the margin, and we're going to have a discussion after, so you guys can go ahead and get started on your reading. Okay, you guys all finished up with the reading? Okay,
Yes.
so now we're gonna kind of have a group discussion, get with a partner, get with a group, and kind of go over what you guys highlighted, any questions you had. I'll walk around and see some of your questions and try to help you out on anything you guys can be confused about. So,
Would you highlight?
On the first page, I highlighted the wall.
I did too.
Oh.
Because it's a reasonable guess.
Yeah.
It makes sense why you
Yeah.
think
when
that.
you first started this thing.
Yeah. And this.
I didn't highlight anything.
But then it makes sense later because he talks about how we're not right angles, that's where they're crooked.
Yeah.
And then I thought it was funny they kept saying the right angle even if they weren't talking about
And these don't have 90-degree angles.
No, they do not.
Right.
That's why they don't work.
Mhm.
Because look over here. He has a 90-degree.
Yes,
Right,
they're
first started
starting
using that.
with the 3 and the 4 and the 5.
Right.
Yes.
So towards the end of the story, did you guys figure out like what the actual formula was? Did we get to a conclusion, do we think? Did we agree on that?
I
Yes.
think so. I think it's.
I think so too. I wrote it down into my book.
So what conclusion did we get to?
I think we got.
I think the formula is a squared
Mhm.
plus b squared is equal to c squared.
Yeah, I
Yes,
think
definitely.
so too. Because he talks a lot about how one side plus one side equals the other side. He
Squared.
talks about squaring, multiplying one number by itself.
Yeah.
So yeah, he's a pretty smart little dude.
He was really happy too.
Yeah. Pythagoras.
Yes. So we can kind of come back together once everyone's done with your discussions, wrapping up. So I saw a lot of you talked about some of the triangles weren't right angles, and he was kind of curious at first, like, why was this working? And they did refer to right angles a lot, because that's one thing that's important is that we can only use right angles with the Pythagorean theorem. So kind of coming together, was anyone able to discover the formula from the reading and take out that important aspect? So yes, Al.
A squared plus b squared equals c squared.
Yes, great. So our formula for Pythagorean theorem is a squared plus b squared equals c squared, which from our bell work, we know that the c is the hypotenuse or the slanted side. So anytime you're wanting to know what's on the other side of the equal sign, it's always that. And always remember to square those when you're using the formula as well. So kind of to just take some of our knowledge and practice using that formula, we have a couple practice problems to apply just from using what you learned from the reading. So if you have any questions, you can go ahead and ask them. But I think from the reading, you guys should be able to do these quick little practice problems. And the questions will be asking to solve for certain sides. So remember to pay attention to what side it's asking you to find. Is everyone finished up with the practice problems?
Mhm.
So does anyone want to go through and explain their work using the formula that we found? Do you want to explain the first one, Maggie, kind of your work that you did?
Yes, so I did 4 squared plus 3 squared is equal to c squared.
So how did you know that those were A and B?
Because they weren't on the hypotenuse.
Yeah, good job. So we were able to plug in our numbers and then we
Yes.
found C squared. So when you have C squared, what do you have to make sure you do to find C then?
Take the square root.
Take the square root. So yeah, that's something that we need to remember. When it's squared, to get it by itself, we need to take the square root. So
And
what
my-
did you get as C?
My answer was 5.
5. Good job. Okay, Allie, do you want to go through the second one maybe and why it's a little different?
Yeah, so this one you were finding B, they gave you C. So you had to write 5 squared plus B squared equals 13 squared. And then you had to do some algebra and subtract and square root. And you got 12.
Yeah, so we definitely applied our past knowledge from our algebra classes, so that's great to incorporate that as well. So now we're going to do kind of an activity to go over why this works, and we're going to model this using squares and triangles to show that we can prove that this is true, because you can think, oh, why does this work? So we're actually going to go over that and prove that that's true with this little activity. So to start off, I'll kind of show you what we're going to be doing. I'll pass these out first, but don't get started on it yet. So I'll get a little set. And so to start off, if you see here, we have a square that is C by C dimensions, which would be the C squared. So that's our large square. We have a smaller square that's B by B, which is the B squared. And then we have A by A, which is A squared. So if you set up this little diagram, if you look on page 19 of your story actually, there should be one very similar. And that's what we're going to be referencing in our story, is the diagram that he made with the same squares and triangle for the from the story. And they should be highlighted that actually match your shapes, just so you have a little bit of reference. So you can go ahead and make the diagram that's from the story, and we can see if we can kind of create the same shape that Pythagoras did.
What are you doing?
We're doing class. We're in class.
Okay, so did everyone make the same diagram from page 19?
Yes.
Yeah, so we can see that there's 2 squares that are pink, which are the A's and B's like we have, and then we have the right triangle in the middle. So to kind of prove this, if you look on your B square, there should be some lines that we're going to be cutting on that we're going to make to fit into the C square. So we're going to cut just on those lines, and they're going to make a little bit of a triangle shape. So you're going to cut along those like this, and I will give out the scissors when I'm done with this. So cut along the lines. And yeah, they might not line up right on the corners, which that's okay. That's how we're going to make it fit. And if we notice in the story, he figured out that the tiles of the 2 smaller squares equal the big square. So that's kind of what we're proving is his thinking using these little squares that we made. So if we take our C squared and we take our little triangles that we just cut out and we put them in each corner, the flat sides should line up with a pointed side like this. If you're having trouble, I can help you try to place them if you're not getting them to fit. And then if you see, there should be a square left in the middle. And if we look at our shapes, what shape do we discover that equals? What shape is this, Allie?
Squared.
The A squared
A
piece.
squared.
The A squared piece.
So, yeah, if you make it like that, then there should be a square in the middle, and we're able to put that. And so if you look here, as we cut up the B squared plus the A squared, it matches the same size as the C squared. So that proves that the theorem is right, and that's kind of what Pythagoras thought and discovered on the page from our story. So yeah, this was just a little neat activity to show that this actually works and was discovered. Does anyone have any questions about that? Yeah, and if you put them side by side, Allie, that's awesome. Look at it that way. So next we're gonna get into some writing, following our reading and kind of practice our thinking a little bit deeper. So one thing that I want you guys to do is I want everyone to get out a piece of paper now for our writing activity. And I want you guys to try to come up with a situation or problem on your own, kind of how Pythagoras thought with the ladder, like, oh, how tall does the ladder need to be, or how long does it take to travel somewhere on a boat? So try to come up with, like, be creative, come up with a situation like, how big does something need to be, or how far do I need to travel using the Pythagorean theorem? And as you guys compose those questions and publish your own writing, we're going to switch them with classmates and solve one another's problems. So be creative. If you have any questions, let me know, and then we'll solve one of those problems. So thanks for